We're going to look at solving rational equations. A rational equation is any equation that is going to be in the form basically kind of fraction equal to fraction, where instead or fraction equal to a number. But the big thing is that the variable is going to show up in a denominator. So for example, in number 1, I have the constant function -4 over the linear function 5x plus 10. So those functions combine to make one rational function. Kind of same thing on the right. One thing you want to be careful of with rational functions is that you can have extraneous solutions. Remember, we've talked about extraneous solutions before. We talked about them with absolute value equations. Extraneous solutions, again, are going to be solutions that you get after going through your solving process that do not work after you check your answer. So I'm going to say solution. So I'm going to simplify that definition a little bit. Solutions that do not work in the original equation. So we always want to check for those. Backing up a little bit, you should know how to solve equations in the form fraction equals fraction. If I want to solve something in the form fraction equals fraction, that is when I cross multiply. I know you're really excited to hear that because I have students wanting to cross multiply every time they see a fraction. Whether they're adding, they're subtracting, they're multiplying, they're dividing. It doesn't matter what. They always just want to cross multiply. So here you go. You get to cross multiply. So I am going to also change example 2 a little bit because we have not talked yet about how to solve quadratic equations. So example 1, I'm going to go ahead to solve this. I'm going to cross multiply. I'll multiply those together. I'll multiply these together. Big thing to remember is that x plus 2 is currently grouped together underneath that fraction bar. Parentheses are a way to group things. Fraction bars are also a way to group things. So since x and 2 are being grouped together, once I get rid of that fraction bar, I'm going to have to still show they're being grouped together, so I'm going to have to transition to parentheses. So I will have -4 times x plus 2 equals 3 times 5x plus 10. Now I can go ahead and solve this because notice now that I've cross multiplied, I've taken those 2 rational equations, and now I instead have a linear equation. All right, instead of having a rational equation, I now have a linear equation. So I'll start by distributing the -4, -4x minus 8. I'll distribute the 3, 15x plus 30. Combine like terms on each side, which I do not have any, so I only have one variable. So I'll combine my x's. -8 equals 19x plus 30. In trying to isolate the variable, I'll subtract 30. And I get -38 equals 19x. Dividing by 19. My 19's cancel. I'm left with x equals -2 if I check my solution. So with rational functions or rational equations, when I'm checking to see if my solution works in the original equation, what I'm really checking to make sure of is that by plugging that back in, I do not get a 0 in the denominator. So I'm going to add that into this here. So no zeros in the denominator. No zeros in the denominator. So you may have seen me do this before. I often tell my students to help you remember, it is okay to have 0 on top. It's just 0. But no, it's not okay to have 0 on the bottom. That is undefined. And if you think about when you've talked before about linear equations, we talk about having an undefined slope if we have a 0 on the bottom. Can't have 0 on the bottom. Not okay in math. So plugging this -2 back into my original equation, I end up with -4 over 5 times -2 plus 10. Is that truly equal to 3 over -2 plus 2? Let's make sure that that really is equal. So I end up with -4 over -10 plus 10. And over here I end up with 3 over 0, which does not make any sense. Since that does not make sense, since that is undefined, I'm going to see that even though I got x equals -2, it didn't work. So I really have no solution to this rational equation. The one answer I got was extraneous. Looking at example 2, remember when I said I'm going to change something? This is what I'm changing. It should not have this square on the bottom. We have not yet learned how to solve quadratic equation. So store that away. You'll learn it this year, just not quite yet. So I'm going to go ahead and solve this by cross multiplying. Again, I'm going to group the x minus 2 and the x minus 4 together. So I'm going to have negative 2 times x minus 4 equals 2 times x minus 2. That gives me negative 2x plus 8 equals 2x minus 4 after I distribute. Let's see, add 2x here, add 2x here. I get 8 equals 4x minus 4. Add 4 here, add 4 here, working to isolate that variable. 12 equals 4x. Now I can isolate it further by dividing the 4 away. Those cancel, reduce to 1. 1x is the same thing as just x. 12 divided by 4 is 3. So I get x equals 3. Again, I have to go back and make sure that works. So does negative 2 over 3 minus 2 actually equal 2 over 3 minus 4? So that gives me negative 2 over 1. That gives me 2 over negative 1. Because it does not matter where the negative is. Negative 2 divided by 1 is negative 2. 2 divided by negative 1 is negative 2. The negative can be on top or bottom. The whole thing is negative. So yes, this really truly does equal each other. So x equals 3 is my only solution, and it did work, so I don't have to worry about extraneous solutions. And those are my only 2 examples. So hopefully that made sense. If it didn't, make sure you mark on your notes somewhere what was not making sense to you and what you're struggling with, so we can talk about it tomorrow in class.